Woohoo! Oops, my coffee is in the straw. And it's gonna be in the shot because I'm still drinking it. Good morning! It's a fine Wednesday morning. Wonderful temperature outside. I have the door open. You can't see it, but it's over there. It's over... Wait, I have two cameras. It's over that way. Which is actually the opposite of where this is facing. Weird. Huh. That's gonna bend my brain if I think about it too much. Good morning, Leah. So yeah, today, I have some fun stuff. I did yesterday get my Zephyr build environment up and running, which you can see over here. I was able to build the Blinky sample, which runs on my Seeeduino. Brain there. Autofocus is off, so you can't see it, but it runs on this and it blinks. It's not running right now, obviously, because it's not plugged in. So I've got a Zephyr build environment, I have a ZMK build environment, and I also, you'll notice, I have now shiny new CircuitPython build environment. So last night I cheated a little bit. I got the build environment up and running, and I'm like, okay, let me start exploring this. How do I even use this? And fun story, so I think I talked a lot about the resistor on the back of this thing on R1, and it's like, okay, if R1 is present, it's SPI. If R1 is not present, it's I2C. I said that repeatedly. I thought about it repeatedly while I was hooking this thing up and like messing around with everything. And then I get into CircuitPython and I'm like, okay, cool, I'm gonna do this with or with I2C. And I'm like, okay, well, so there's like a demo or like a proof of concept little thing that scans for all the I2C devices on the I2C bus. And I got that working. Except it wasn't detecting this. And I wasn't sure why. So I'm messing around with it. I switched the wires. I got some weird errors about being not pulled up or whatever. And then I was like, you know what? I'm going to try an I2C device that I know works. Right here. An OLED display. I plugged that in. Boom. Worked perfectly right out of the box. I'm like, why is this not working? So I go and look at the spec sheet, which is not this, but it's similar looking. And then I realized that it's because it's set up for SPI, because there's resistors present. So that was fun. But I at least had functioning CircuitPython running on my Raspberry Pi Pico that was scanning the SPI bus and detecting the OLED display. So I call that a win. However, you'll notice that I am not using today the Raspberry Pi Pico for this experiment, or for this playing around. And the primary reason for that is this board, the Seeeduino XIAO, runs both CircuitPython, and I have I have built firmware to built Zephyr firmware to run on this and run it on there. So that's two different things, two different ways I can play around with this. One, CircuitPython, which there's a REPL, there's, you know, it's Python, so it's a little easier, at least for me, to wrap my head around. I'm not doing quite so much gymnastics to get C code working. I can just throw a couple of lines of Python in here and click save, and it's running on the thing. So my goal today, or my goal for this next part of this process, is to kind of read through the spec sheet over here. So this actually talks about how to talk to the input device. This talks about like the protocol that you speak over SPI or I2C, and I2C, and then the SPI, like here's how to actually, here's how to read a register, here are the registers to read, and that sort of thing. So my goal today is to get, at least in CircuitPython, to read the firmware ID, to read any of this stuff from the controller or from the trackpad. One thing I think is really cool about this, and this is getting a little nerdy, but I mean, this is kind of a nerdy stream, so it's fine. So the way SPI works is you have an input channel and an output channel, and then you have a device selector and a clock, right? So the clock is basically like, okay, there's another bit, there's another bit. It goes on then off, or the other way around, I don't remember. But it just flips itself. And every time it flips on and off, you read another bit, or you read another level off of the input or output, or write to your output line. And that works great. And then the device selector is so you can have multiple devices on the SPI bus, but only one of them talks at a time. And the talking is all driven by the master, the host. So the master goes, okay, hey, it's your turn, and it sets this pin to low, and then you just write based on the clock, or read from it based on the clock, whatever the case may be. Except this, being an input device, your input is not necessarily, the input to the actual device is not necessarily coming from just the controller. You can set this up to pull the position, everything off of this if you want to. I'm not actually certain you can, but in theory, like in a world where you're designing this, you can make it so, the controller loops through the SPI devices and it's like, hey, what's your state, and gets the state dump and then moves on to the next one. But this actually has a pin that you can set to read from, and it's called the data ready pin, and it's basically like, hey, I'm ready to go. It's an interrupt pin, which is awesome for power consumption, because that means the device drives it and the controller can just sit there and sleep and do nothing while it's waiting. So I thought that was really cool. I'm sure this is very obvious to a lot of you or something like that, but to me this is very new and very fun, and I'm excited about it. So the crazy thing about it though is, what it means is, instead of 4 pins like you have with I2C, you have ground, VCC, a clock, and I2C, or SCL and SDA. So clock and data. You have, on this board, 7. You need VCC ground, you need data in, data out, and you need ready in, ready out, and a clock. So it's like, it's not actually ready in, it's more like, hey, you're the device that's ready to do things, but the ready pin is kind of the ready out. So anyways, I thought that was really interesting. Yeah, so I had written down yesterday on this little post-it, like, things I want to try. The first one was list devices on the I2C bus, and I crossed it off because I managed to do that. Then get the Blinky demo working in Zephyr on the Seeeduino, scratch that off because it's ready to go. So the next one I looked at, or the next one I wrote down is on the Seeeduino, is there like, apparently some pins are interruptible and some aren't on some controllers. That's a thing that I just found out about when I was reading last night. And on the Seeeduino, apparently all of them are interruptible, so I can use any pins I want. So what I've got going on here, the plan for this is, this, oh, you can't see it because it's hidden. Let me, oh, you can see it in the background behind the spec doc. I've got too many windows open and it's hard to really grid them all on here. So we've got we've got ground 3.3 volts. Oh, you can't see my mouse pointer either. Well, that's just handy. Okay. Anyways, going down the right side of the... Huh. I hadn't thought about that, but maybe. I'll look into it. I'm gonna proof of concept this first, and then look into optimizing pins. But really, I think in the long term, if I can't... Like, if I think I2C is actually going to be better for this, because of interrupts or something like that, I'll probably do that. But otherwise, like, it's an extra pin. There are plenty of pins, so I'm not too concerned about it. Anyways, so down the right-hand side here, we've got the ground pin, the 3v3 pin, and then over on the very far right of the... God, I really wish I could point to this. Is there like a... laser pointer thing? Sorry, do a little detour here. OBS. Oh wait, I can do that here. OBS laser pointer. Option to highlight cursor and mouse clicks. How do I use pointer? Aha. Double click on Nope. Okay. I'll look it up later. I'll figure that out later. But so going down the right side, the pins on the right side, you got 5 volt, which we're not using, ground, which we are, 3v3, which is VCC, but it's 3 volt, or 3.3 volts rather. We're using that pin. Then we've got MOSI and MISO, and those are actually acronyms that mean master out, sensor in. So it's a real easy way to remember which is the output pin from the controller and which is the input pin on the sensor, because this is, you could consider this a sensor because it really is sensing where your finger is and stuff like that. And then you've got MISO, which is master in, sensor out, and then SCK, which is the signal clock or whatever. It's the clock line. Then there aren't actually pins for device select or device or read ready, because, and I think the reason for that is because with device select, you're telling a specific device, hey, it's your turn. So it doesn't make sense to just have one pin for that, because you need one for each device that you're trying to connect to. In this case, we only have one on the bus, but you just use one of the other pins basically. So that RX at the bottom there, that's for UART if you look at the color code stuff. But I'm going to use that for the thing. Sorry, I got distracted by chat. So I'm going to use that for the device select or CS, SS. There's a bunch of different acronyms that I've seen for it, but it's basically like, hey, it's your turn. And then I'm going to use over on the left hand side pin 6 for the device ready pin. So that's kind of the idea, and I've got that written on a post-it here. And what I'm kind of hoping for, so this here is the Seeeduino expansion board, they call it. It's kind of hard to see from this angle, but basically you plop the Seeeduino in there, which looks a lot like this, and it breaks out all the pins for you on the side so you can plug stuff into it. but it also sets up like these are I2C connectors, so you can just plug more I2C devices in there if you want. That's UART. That's something else. I don't know. I'm not using it, so it doesn't matter. There's like an extra user button here. There's a reset button. There's, you know, battery connector and charging circuitry and stuff like that. So like this is a pretty fully featured little like breakout board, more so than just your standard breadboard. One awesome thing it has is an OLED display in the middle there. And what I'm hoping to do as kind of a like proof of concept that I've got it working is, assuming the OLED display functionality is fairly straightforward to set up in CircuitPython, which I think it is. Like I need to download a library maybe, but then it just works. I want to have that be like a running list of all of the positions that are reported by this. But we'll first just have it spit it out to the console here. Not even the version. The first thing I'm gonna go for is the firmware ID, or not, sorry, not position, but first thing I'm gonna go for is the firmware ID and firmware version. And what's awesome is this documentation talks about like, so those are the actual registers you read from. This is very familiar to me from trying to do Bluetooth low energy programming, where you have these device characteristics, which I kind of feel are basically like file descriptors, but like the device plops a little thing in there and you read it, and the device plops more in there and you read it, and there's a way to get kind of an interrupt when there's more ready to go, and so you can subscribe to that and just constantly read off this thing or write to it, as the case may be. So this is very familiar kind of operating mode where you're like waiting for a notification, hey, read this address basically, to get the data you want, and then in this case you reset a flag, and that makes the device available to write the next bit, or the next, you know, like store more stuff in the registers. But this talks about like, so there's data ready, yeah, but there's let's see, button data, absolute data packet. It even talks about different power modes, which are really cool. So this will go into low power savings mode, and you can tell when it does that and stuff like that. But it has like a example startup sequence. Here we go. So following summarizes the typical sequence to use Pinnacle. Pinnacle being the ASIC that's on here. They call it Pinnacle. Power on reset, which is described somewhere else in the document. The host clears the command complete flag. So you write to the register that command complete exists in, which is kind of the channel for notifying or something like that. Host configures intended bits. Host enables preferred output mode and enables the feed. Host continually monitors DR pin for Pinnacle data ready interrupt, and then basically when received reads the appropriate data packet and clears the data ready, and then in a loop basically. So what I'm going to start with is power on reset, clear the command complete, and then instead of host configures intended bits of registers 03 and 05, we will just read the version, read the firmware ID and firmware version off of this. Oh, I'm sorry. I had it shown and then took it off. Okay, there. Let me go back down to what I was talking about. Docs, example code. Okay, so here we go. Power on reset. Clear the the command complete flag. Configure intended bits of registers 03 and 05. host enables the preferred output mode. It talks about detection, all that stuff. And then continuously monitors the data ready pin. So you just kind of sit in a loop on the data ready pin, and whenever it goes active, you go, okay, I'm going to read the registers, and I'm going to clear the data ready flag, and I'm going to go back to sleep. And it just keeps doing that in a loop. So that's a very familiar pattern for me. Like, thinking about how... the other way you would maybe do that kind of setup is you would set a timer, you would read from read the device state, and then set another timer, read the device state again, X amount of time later, a polling type of setup, whereas this is like push. And polling, not P-U-L-L-I-N-G, but also kind of that. But this is like every time, you know, presumably every time there's a finger movement, either, you know, it gets pushed down or whatever, that data ready pin will get activated, and then you read the registers and get the information. And the idea is that you do this fast enough that you get that fine-grained information about where the finger is on the board. And it also talks in here about how how that data looks on the line. So absolute data packet, but there's okay, so it also has two different operating modes. There's absolute mode, where it will say like where on the trackpad your finger is, and then relative, which is like, okay, it's here, I move it a little bit, and it'll say, oh, well, you moved it three bits to the right, and then you move it to the left, and it's like, oh, I moved it 10 bits to the left. Or it's like, okay, this is at, you know, 1010, this is at 2020, and this is at 3030, something like that. So, and then this also has support for buttons, because this can be used as a PS2 mouse as is. Like, you wire this thing up correctly to a PS2 connector, plug it into a PS2 port on a computer, works as a PS2 mouse. It's kind of crazy. But of course, if you're doing that, you probably need a couple of buttons. So there's support on here to wire up 3 buttons, which I think is really cool. But I'm not going to be using that, because I just want the touchpad part of it, because my buttons will be keys on the board or some other thing. Maybe software will have tap detection. I don't know. I'm just starting with the basics here, start reading from the device and go from there. Yeah, so this should be fun. Yeah, it talks about this register access protocol wrap. And it's just, you know, read to the register. It's like commands that you send to the thing. And yeah. It's actually a pretty neat way to do this, I think. Part of me wishes that it was just a stream of bytes that I could read, or stream of bits that I could read off of the line. And then there would be another pin that's like, okay, wait, actually we need to do something else real quick. But meanwhile, it just keeps streaming down all the movements. But I feel like the interrupt, read, write, or interrupt, write, read loop, it would be quick enough. And it also talks in here lower down about pipelining commands. Like, I feel like that if you do it quickly enough, it's probably fine. I don't know. We'll see. I'll be very happy to just get the firmware ID and version off of this. Hello, Lorenzo. This is the small version of this, which is a Cirque glide point trackpad. It's a capacitive trackpad. I'm pretty sure it doesn't support multi-touch, but I don't care about that for the purpose that I want of this. And I'm trying to write well, ultimately I'm trying to write support for this into ZMK so I can make a little module that drops onto the Zephyr, among other things, to put a trackpad into a keyboard. But today's goal, it'll be awesome if I get there, is to read the firmware ID and version off of the board itself. So, one thing I didn't do is install CircuitPython on here. Oh, so I think I might have covered it a little bit, but the main reason I'm choosing the Seeeduino over a Pi Pico or a nice Nano for playing around with this stuff is mostly that the Seeeduino has like an actual page on the Zephyr website, and it supports CircuitPython natively. So, and I've already built firmware. I've already built Zephyr firmware for the Seeeduino, and presumably installing CircuitPython on this won't be too hard. So I can use the same board, the same pins, the same everything, and hack on both. Ultimately, the plan is to get it into the nice Nano with ZMK, but and I'm pretty sure I can just say, like, you know, tell Zephyr to build for whatever board is on the nice Nano, which is like an NRF something. But I don't really know how to do that. I know how to do this. So I'm gonna go with what I know, because it should be directly portable. It's talking SPI, so I just set up the pins, whatever. But we'll see. Because like Zephyr, I don't think runs on the Pi Pico yet, and I don't want to try to get CircuitPython going on here. I'm gonna stick with the one thing that can do both for experimentation, because I think it is probably the better approach for me. So that's why I'm doing that. So now I need to figure out what's this. Oh, and I started to look at someone else's code a little bit for this. Or no, this is Cirque's code. So I started looking at Cirque's code for doing this. But I then found when I was looking in these docs over here, oh, you can't see my browser. Okay. When I was looking in okay, here. There's a Seeeduino page on Zephyr's web. You can't see it. It's a Seeeduino page on Zephyr's website. I too many windows. I want to have them all up at once. But I don't want to just share the whole screen, because then you wouldn't be able to read anything, and you would see like my face 8 times because I've got different streaming windows going for this. Anyways, so the thing I want to do right now is okay, so this is actually the code for just for Arduino, using this with an Arduino. So there's a bunch of code there already. I could probably just port this directly over. I'm not going to, but I could probably do it. Because I was like, okay, well, I see how this, you know, when I was looking through the docs, and this is going to get annoying. When I was looking through the docs about SPI, it's like register access using SPI, and I'm like, great. That's great. What are these registers? How do I use them? Whatever. I'm not realizing that I was like 3/4 of the way down the document. So when I scrolled back up, I found all of this stuff, and I'm like, okay, this makes more sense. So I didn't need this as much anymore. So I'm gonna close this for now. But one thing I want to do is... and I don't need that. Don't need that for now. Might need this in a little bit. What I'm gonna do here is... Sorry, I keep switching back to Safari and then not showing. Seeeduino CircuitPython. Okay. Plug this in here. Okay, and if you look here, next to my, or between my thumbs, you can see that blinking light. That is the result of the other firmware that I installed, or that I built, the Zephyr. So this is running Zephyr right now. This blinky light over here is actually the battery charge indicator, so I didn't want to confuse people, but this is that's the actual light that's blinking. So proof that it works. And also I plugged it in and turned it on and it didn't let the smoke out, so I must have it wired at least not so poorly that it is gonna break. Also, just remembered, I've got a banana for later because I'm probably gonna need it. Okay, so I downloaded that, so I need to double tap the reset button on there, which gets me my Arduino device, and then drag this onto there. And that should be running CircuitPython. Okay, detected a new CircuitPython device. So let's see. Okay. Whatever, this works. So, we've got this here. I'm going to be stealing from a lot of things. So, CircuitPython, SPI example. Sure. So, import board, import bus IO, import okay, so these imports, as far as I can tell, the board is kind of like the definition of the board. It's got all the pins on the board, it's got things like that. Bus IO is kind of like wrappers for different protocol things. So it has a constructor for, for doing SPI. It has a constructor for doing I2C, and you use digital I/O to actually control the pins themselves. So you can take a pin and set types of pins and stuff like that. So you take like a bus IO dot I2C and tell it which pins to use for I2C, and it just does everything for you. And it also has two different implementations that it can use. There's a controller native implementation if your controller natively supports SPI and I2C, which this does. And I think so does the Nice Nano, and I think so does the Raspberry Pi Pico. So it can use the hardware implementation of that and just get the stream of data much easier. Or what's called bit banging, where it's just literally going like on off real quick on the pin. which is less efficient because it's doing all that processing in software instead of at the hardware level. But the CircuitPython supports both methods, and I think transparently, like it just knows based on the pin or the board. I don't really know. But in this case, what we do is, so the CS line is just a simple digital I/O line. So CS is the or SS or whatever. It's the device selector. So on this board, or on this setup, we're using D7 as the CS pin. So we want CS equals digital IO dot digital in out or dot D6, no, D7. Okay, and then CS dot direction. So we set it up as a right pin. Dot output. No. Okay, so we set it as a direction or as an output, and then we set the pin to true, which makes it go on, basically. Apparently, SPI, there are some devices where the CS is inverted, but it's rare, and people say don't worry too much about it. I don't know. I'm not worried too much about it. Okay, so we also want the read-ready pin, digital IO dot digital in out dot 4.6, and then R dot direction equals digital dot direction dot input. Okay, so that's good. And then we want to set up the SPI interface. SPI equals bus IO dot SPI, and then we clock, which is actually I wonder if we can just board dot hang on. If I play around with this too much more, what I want to do is figure out a way to make this work in Emacs instead of through this editor, just because this editor is not my editor that I spent weeks setting up. I was going to say years, but honestly it was about weeks, because I switched from Vim to Emacs a couple years ago. Okay, so this should be main.py, I think, or code.py. I don't know, we'll see. 0. Just want to enter the REPL. So board. Oh. Okay, that's just a wrapper around bus IO. Okay. I was really hoping there would be, so you've got the A, D, whatever pins. Oh no, there is. So I can just do clock equals, okay, sorry. I was really hoping that these would be here. So there's the clock, but there's miso and mosi. So I can just do board.sk, mosi equals board.mosi, miso equals board.so. You can't do that on the Raspberry Pi Pico because the Raspberry Pi Pico doesn't define those in the board module because it has multiple SPI and I2C stuff interfaces. So you just give it the actual pin to use. That's why I was like, I wonder if it has this, because apparently some boards have in their definitions in the CircuitPython code to do this. Okay, so something that blows my mind is that this down here, this is a REPL, which is a read, evaluate, print loop. Basically, it's a command line terminal shell that's actually running on this. And what I say by running on this, I mean, if I do board dot, or if I write some code in here and execute it, that code is actually running on this controller, but I'm doing it interactively, and it just blows my mind. I just think it's cool. I'm entering a whole new world of microcontroller things, and it's cool because, like, in my brain, running code on a microcontroller is like, okay, well, you gotta write all this stuff and you gotta compile it and then flash the firmware and do this and all this stuff, and it's like, no, or you just open a terminal into your microcontroller and then just write some Python in your shell. And there you go. It's very similar to the first time I used a Raspberry Pi with Linux on it. I was like, there's Linux running on this tiny little thing, and it's a full-fledged Linux box. And it's just this tiny little computer. I've got one of them sitting on my desk right here. Actually, I have a second one sitting on my desk too, I think, but it's not plugged in. I don't know. Just kind of blown away by some of this stuff, some of the cool innovations that people do. One thing that is a little frustrating, and this is coming from a former Ruby developer, is that this REPL is not, like, in the context of this running code. So in Ruby, there's this thing called pry. So you can do, like, binding.pry. And, well, you first have to require pry. And that drops you into a REPL in that context. So I can look in the REPL at SPI, at RR, at CS. I can manipulate things. I can do whatever. It's a nice debugging thing. I imagine Python has it. I don't know if CircuitPython has it. I'm not going to go trying for it. Because one other thing you can do is just copy paste all this into here and run it. Which is what I'm probably going to end up doing a lot of. But yeah. And then, like, if I exit out of this, it resets the controller. So if I do, like, print hello world, save that. Yeah, well, I guess print doesn't work, but whatever. It automatically, I guess it doesn't necessarily reset the controller, but it restarts the Python program, which just this whole, it's so cool. I can write Python interactively and run it on a microcontroller. It just blows my mind. Anyways, so what we want to do, for most chips, they expect the CS line to be held high when they aren't in use and pulled low when the processor is talking to them. Okay, so while not spi.try lock. So what this does is tries to lock the SPI bus, and I think this is mostly for multi-threaded or event-driven or some other applications where there might be multiple things trying to read and write from the SPI bus. So this basically just says, like, okay, I'm going to take the SPI bus over for a minute. So basically it just sits here and spins on a loop until try lock returns true, which means it got the lock. And then we spi.configure baud rate equals 5 million. I don't know what phase and polarity do, but we'll see if that needs to change. But the baud rate is basically how fast the clock flips, or the clock line flips, and this is 5 megahertz. And the specs on this board say it can go up to 13 megahertz, so 5 megahertz is plenty. Like import main.py. Oh, let's see. Can I just do that? Control D. Import main.py. I don't know. Probably, but I would probably need to reformat this as a, I was going to say as a module, because that's what Ruby would call it, but as a class. So instead of it just writing a bunch of code here, it'd be like defining a class, and then I could interact with the class. And I don't feel like doing that right now. Okay, so cs.value equals false. So that tells the... Okay. This is where it's going to get a little tricky. So what I want to do here... So I think the way... Okay, so this, like I was saying, this is where it gets a little tricky. I think the overall loop I want to do here is cs.value equals false. Let's just say spi.write, for lack of a better thing. Write read register 0x00, right? And then spi.read, and then cs.value equals true. Something like that. If only there was a thing that described exactly how to do that. Register access using SPI. Reading a register using SPI. SPI requires 2 exchanges when reading register. The host starts by sending the read command byte. The simultaneous response byte may be data read from the previous command, or it may be a filler byte. Okay, 3 additional bytes with the value of 0xFB must be sent after the read command to allow Pinnacle to respond. The response will be sent during the transmission of the final byte. And then you read... Oh, that's funny. 0xFB for filler byte. Okay. So what I want to do here is look up the CircuitPython SPI library. Oh wait. No. So that's reading, but how do I write to it? Oh, right. There we go. Okay, so... XIAO, so... Yes, SPI dot. Right. Bytes, and then zero X. Okay, so read board with can I? Oops. Oh no, wait. Sorry, I'm getting ahead of myself. Before I startup sequence, clear flags. Okay, so let's, before we do anything else, okay, let's implement the startup sequence. And this is where I really wish I had Emacs, because I could comment this very quickly instead of having to do this manually. Okay, so clear flags, host clears SWCC, writes value to register 00. So we want write value 000 to register 002. Okay. I'm gonna skip the host configures intended. Damn it. I'm gonna skip this part, I think. Or sorry, this part. And I'm definitely skipping that part right now. So I'm gonna clear this and then try to read this. Okay. So reading a register using SPI. How about writing a register? Writing to a register. Okay, so write value 0x00 to register 0x02. So I need to SPI OR operator to write equals 0x80. So then if I do SPI dot okay, so then we do SPI.write lights, and then we just want 0 0x00. Read into result. Okay. And then cs.value equals true. Huh? CircuitPython print to 0. Oh wait. Let's see. Code done run. Why isn't that showing me? The output though. Nada. Okay, something isn't right. I think it's supposed to be code.py, not main.py. I think that might be part of it. There we go. That's much better. Okay. I knew I was doing something wrong. So it's code.py, not main.py. Boom. Alright, so what do we got here? Print. Result is... Okay. Whatever. It's giving me FD for some reason. Don't know why. But I think I have it actually working, maybe. So I'm just going to try SPI.write. And I want to bytes read and I want to read. Zero. Okay, so I know I could probably do this all in one write then read, but what I want to do is I want to just have a little more control over things, a little more visibility. All right, let's see if that does the trick. Nope, it's FD. Well, the nice thing about the... I'll get to where I'm using the REPL. Before I do that, I need to... Because I'm going to turn this into a function, right? Because this is ridiculous. This is absolutely ridiculous. Why is it only reading FD? And this is still way, way faster than, like, write a bunch of C, compile it, flip it over onto, you know, flash it over onto the controller and wait, and hopefully it works. So we'll get there. Data output, power modes, touch tension, serial peripheral interface. interface. Sample startup sequence. I'm gonna look back at this one. Okay, so there's, you can't see the mouse pointer, but it's a, like over here, it's a, you know, highlight some text thing or select some text. Hovering over the data output, it's got a little pointer, like you can click on it and you click on it and it does nothing. That's like, that would be awesome if that was a link to the actual page. Okay. Okay. So feed config 1 is register 0x04. And if I want to disable the feed, which I do want to do right now because I don't want to have to screw around with the interrupt, then I want to just give it, I want to make sure bit 0 is 0. And since I'm turning it off, I don't care about any of the rest of them, so I'll just do 0x00. Okay. Oh. No. Yeah, okay. SPI dot. Read into okay. So I have a feeling no, never mind. I was gonna say I have a feeling I need to clear the command complete done register after doing this, but I don't think so. And just a minute, I have a phone call. It's probably nothing, but I need to check real quick. Yeah, they're trying to call me about my car's extended warranty. Contains system operation and configuration bits. So let's see. Table 9 on page 13. Okay, so I don't need to worry about that. Okay, so for good measure, I'm going to clear this again. And then I should be able to hopefully read the stuff. Result is FD, 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 FD. Maybe it's trying to tell me FD stands for fucked, and it's trying to tell me that this is fucked. Mm. Let's just read 42 bytes off of it. See what happens. Yeah, I'm screwing something up somewhere. Oh wait, rinse. There we go. I was screwing up the format. I wanted to print, so I wanted this X here to format everything as, excuse me, as hex. But I don't know why this didn't print out. See, what's funny is I'm way better at Python than I am at C, and clearly I suck at Python. Ah, it's still FD. Why? Okay, so I think that might be... I set... Damn it. Why does it keep scrolling down when I click? So value of RR pin is true. Then I try to clear the RR and CC flags, and it's still true. Alright, I want to try something. Pin equals digital IO dot we'll go with D3. Or no. Go D5 since it's right next to things. I'm going way back to basics here. I want to see, can I set a pin manually and read that pin? So that should be D5 because D6 is the read ready pin. So pin dot direction. Oh wait, okay. So pin equals digital IO dot digital in out board dot D5 pin dot direction equals digital IO dot direction input. In dot value is true. Weird. Alright. So I want to connect this to ground. D5 to ground. The ground is already populated. So we're just going to manually touch it there. And it still says true. How about connect to VCC? Ah, I crashed it. Oh dear. Oh, I still have coffee left. Okay, I know what I can do here. I have access to ground pins elsewhere. So what I can do is take one of these, stick it there. All right. Okay, so it's false. Now it's true. Now it's still true, it's false. And if I unhook it entirely, it goes back to true. Okay. Hmm. Hmm. All right, I'm confused. What's interesting is it's consistently giving me FD. Because if I do just this, and then do result, that's all zeros, which is expected. And then if I SPI read into results, actually, what about CSF values? True. Okay, well that's different. Oh my god. But no, that's supposed to go false. That's right, because it's supposed to go cs.value equals false. And then SPI to read into results. Okay, now that's right. Nope. What if it's shifted the other direction? Didn't think so. Okay, so that could be it. I could be getting FB, but it's misaligned by a bit. That's what I was trying to figure out with all that bit shifting and stuff like that. This is much easier to see. Whoa, would you look at that? Oh, can't. I'm doing it again. I suck at this. Okay. Shifted by 1 bit is the common symptom of SPI when the wrong clock setup is used. Either the master and slave disagree on what clock edge data is transferred, or you're starting at the wrong polarity from idle. Okay. This is exactly... Yes. This is exactly the problem I'm having, and probably just means I need to do this configure. Now I gotta go back to the spec. Now I just need to figure out what of this stuff things. Okay, so it starts low and changes when the clock rises. So polarity, base state of the clock. Okay, so polarity is 0. Yeah, and it looks like it's correct, though. The edge of the clock data that is captured, first or second. And rising or falling depends on clock polarity. So, but I wanted to, so the edge is up and then down, right? I wanted to capture the, oh, no. I see. Because there's a delay between when the clock comes in and when that is ready. Okay, so I want the phase to be 1, I think. Boom. Let's try this. Okay, everything blows up. Okay, SPI has no thing called read. That is not what I wanted. Oh. Let's go back a little bit here. SPI read into results. Let's go phase 1. Okay. Hey, look at that. Look at that. It's all FBs. Yay. And the value of the R pin is false. So I am successfully... Yes. Okay. Okay, so result is... Oh, okay. So I want to actually change this back to 1. Oh my god, I learned a thing and I'm so happy. Guess what? Boom. Oh wait. Reading 0x00 result is whatever. X07. That is the value I wanted. It's in the wrong place, but we'll figure that out in a second. So clearing RR and CC flags. So then I want to read, so that's the first read. Second read. Third read. Huh. Three additional bytes. Okay, SPI read example. Does SPI.write, does that return something? No. Okay, well, I don't know about this part, this alignment part, but because this should be, I should be getting at least 2 FBs. So I should, at the very earliest, I should be getting that X07 here. Even if I screwed something up, but it's coming back right away. Okay, well, that's good enough for now, at least, I think. Let's try the next one. So we want to read the firmware version, no, ID. And then firmware version 0x01. So do that. Save. Oh. I didn't actually change it there. What? Okay. I think that just happens to correspond to the ASCII code for colon, is my guess. We're just gonna leave it the way it is. But for some reason, I'm getting the response on the second byte read back, which is strange. I don't think I'm supposed to be getting that. 3A. Okay. Oh, I'm so excited about the bit offset thing. I was like, FD. Like, it's giving me something. It was literally giving me what I wanted. The data. It wasn't reading my commands correctly because I was sending them wrong. But at least in terms of, like, I was reading just like, hey, give me some data. And it's like, yeah, filler byte. Because there's nothing to send. It's like, just here, shut up and take this, right? But it was FD because it was offset by 1 bit. All because of the phase, man. Oh yeah. I still have some Vegemite. And I bought some bread. And it's 2 hours in. I just had a good win here. I feel like, anyways. I just learned a whole bunch about all this stuff, like the fact that it's like, you know, talking about the actual electrical timing and signaling and stuff like that. It's like, okay. Good stuff. So I am going to go get a couple slices of toast. And we're going to do the Vegemite. And y'all are going to get to watch me eat Vegemite. Hopefully correctly this time, because last time I did it, I was like, oh, well, this is like jam. I should put the whole thing on the bread right now. Now, this is way too much for one slice of bread, as it turns out, because that was nasty. But, you know, I've seen the Tom Hanks video where it's like, no, you got to spread it real thin. So we're going to try this. I will be right back with some toast. Okay, so as you can see, I have acquired toast and some butter. So one thing that's awesome about my toaster oven is it's a really wonderful oven, but it's a terrible toaster. This is not toast. This is heated up bread. See that little brown there? That's supposed to be like all over on both sides. But it's what I have. And I don't feel like getting a proper sliced toaster just for the rare occasion that I eat toast. Oh, that's not getting... here. We need to turn off noise suppression filter. We need to get that ASMR buttering sound. That's the first time I've held Vegemite or had Vegemite in since 2018 when I was in New Zealand. But I really want to say that was Marmite, not Vegemite. But I don't remember. That is very Vegemite-y. Okay. So I'm gonna just get a tiny, tiny little slab right here. Just a touch. And I still feel like this is way too much. Turn off autofocus so I can hold it up to the camera. Come on. That's not what I wanted. There we go. Autofocus. So, here's my Vegemited toast. Tasty. And here goes nothing. That is so much better than I remember. It really is. Like before, I just had too much and it just screwed everything. But this just adds a subtle something hard to describe. Just it's a subtle flavor. It tastes a lot like Vegemite. I could almost use a little more on here, I think. Like it's almost getting overwhelmed by the butter. Yeah. See, now I can't smell it anymore. It tastes kind of barley-like, which I think makes sense. Because isn't it made from barley yeast or something like that? Like it's just got this kind of, for lack of a better word, dark flavor. It lingers a little bit, and it's nice. Oh yeah. I may just have to get me a jar of this. It's definitely not a flavor you would want to have on its own. Because it's just way potent. Like it's... And see, even now, like I'm getting desensitized to it, I guess. I like it. I'm trying to think of an analogy where it's like when you put the right amount of salt in something, but it's more than that. Because it enhances flavors, but it also brings its own flavor to the party. But it's just real subtle, but bold. I'm not making these things up. I'm genuinely like trying to describe the experience. Hello, Alex. That might have been a little too much. I wonder if I can cut it by adding more butter. Just kind of go back and forth adding butter and Vegemite until it's like just a big pile. And I didn't bring my water downstairs from upstairs. Adding more butter definitely helped. It's It's like an avocado, where the ripeness of an avocado is a fine point. You've got shit, perfectly ripe, rotten, and it just goes that fast. And this is like that, in the sense of you have not enough, the perfect amount, way too much. And it's real easy to tip over way too much. But if you don't have enough, it's not all there. Like you're lacking. You're like, I taste this, but I want more. And then you add more, and it's like, shit, that was too much. Oh, I haven't busted out the Ferris in a little bit. I did get my new knife tip for my soldering iron, though. All fancy pants knife tip. So at some point I will take that on. That's not a bad idea. Although I imagine living with Vegemite, you would figure out, it becomes muscle memory, right? Like knowing the right amount to put on. It's not like garlic. Garlic, it's really hard to have too much garlic. You can definitely have too much garlic. But the range of like, wow, that's a lot of garlic, to that's too much garlic, is like 40 cloves per cubic centimeter or something like that. Like, it's just such a huge range. I do like it. Let's see if I can successfully recap this. Good enough. Okay. Oh, that was a good experiment. I'm glad I did that. Do I want to leave autofocus on? I do not. Okay. Whoops. Yeah. I accidentally unplugged the controller, and now 8 things on my computer are yelling at me. There. That's good enough. Turn the noise filter back on so I can turn my fan back on. All right. Okay, so what I'm going to try to do here is if we look at the Python docs for SPI, we've got this write read into. And since we know we're going to write our read command, we're going to say read this buffer or this register. And then we're going to read 3 FBs and then our data. We can just do that in one command right here with this write read into. So let's try that. So write read into, and then result. So let's result equals byte array 4. Actually, let's call it 10, just so we can confirm. That also simplifies this code a lot. Okay. Whoops. Hello? Okay. Object with buffer protocol required. Okay. So we want a Python byte array buffer. Okay. Now wait a minute though. Write read into. Because read into is saying it needs a typing writable buffer, which result here is using. So that should work. But I think I'm using write read into wrong. So it needs to go buffer out, buffer in. So this is function missing one, required positional arguments. Maybe this needs to be command equals byte array bytes. Buffer slices must be of equal length. Hello, Maker Jake. Oh, because I didn't print the result. Okay, so okay. Okay, well now it's giving me FBs. I'm flailing here a little bit, but that's okay. Okay, so that actually, this isn't actually reading, right, excuse me, that right read into is not reading anything.
It's gonna be hard to do. It doesn't matter. It doesn't matter. Because what
I suspect it says if buffer slice lengths are both at 0, nothing happens. And I suspect nothing is happening. I'm gonna try out. Start equals 0, out. End equals 5? 4. Yeah. Buffer slices must be of equal number. One, 2, 3, 4, 5, 6. Okay, I'm gonna punt on that for now. Because this was definitely working before. It was just getting weird things. So, command SPI.write. Command SPI.read into results. I swear this was just working a little bit ago. Let me try to get back to all of that. Okay, we're back to it working. Working in an unexpected fashion, but still working. Okay, that's what I expect. There's got to be something going on where because it writes. So I write the command, I write a byte, I write another byte, I write another byte, and that's when I get it. So 4 bytes total. So it's as if the write is doing a read at the same time and then discarding it. Because if we look at it, so this does a write and then a read into, and that's result 1. And then write and read into, and that's result 2. But if we go write and read one, write 1, read 1, and then just read 1, that's 3. Or no, write 1, read, that's 2. Write 1, read 1, then read 1, that's 4. That lines up. But how do I write and get the response at the same time, which I think is what write Okay, one thing that's messing with me a little bit is I've got UART, I've got SPI, and I've got I2C all in the same file in this docs. And so I'm like scrolling around and I don't know which one is which. So I want to collapse this. Can I collapse that? SPI. Okay. Okay, we're gonna try one thing here. We're gonna write read into results that. And then this is actually result 1. This should be result 2. Okay. Object with buffer protocol required. So oops. Oh, it's just byte array. Ugh. I feel like I'm really close to having this, to figuring this out. There we go. So I'm right. But now I wonder if should I need to capture that right? Should I need to capture that that response? Is that possible? Because write read into doesn't seem to do the trick. Because that just does fuck all, it seems like. But this is definitely what's happening. So what I changed here is with read into, you can tell it a value to write to. And I just want to give it, according to the docs over here. According to the spec docs over here, you know, I'm going to do one thing. Because I haven't used the terminal at all. So why even have it up? Honestly. Make this narrower, get rid of the sidebar. There we go. Why didn't I do this earlier? I don't know, but I did it now. So I want to send the byte. I don't really care about the thing because I am always going to always going to read that. So this should always just be a filler byte. But of course, then there's pipeline reads. Reading SPI back to back. Yeah, I'll figure that out. We'll optimize the protocol stuff later. But then what I want to do, I still need to send, you know, filler bytes along with every read. Or I don't need to, I guess, but it wants me to. So the first write. So this is print writing command and discarding output response. Sure. So the read into allows me to say, hey, give me, okay. If I do result equals byte array 3, whoops, undo 3.
I've decided not to leave this town. Maybe I can stay and find some other nice people who will like me and accept me for who I am. Trusting
Maybe.
Yes, that's exactly what I'm talking about.
There we go. So I want to change that to hex. So now we take this. Reading 0x01. And then get rid of this. Okay. So that gives us what we want. And for now, I'm just going to assume that when I do SPI.write, I can't read the output. Don't know why. Don't care. Doesn't really matter. Because, yeah. So now what I can do is kind of boil this down into a SPI or wrap wait, what's wrap right bytes? I wonder where that comes from. Oh, it comes from there. Okay. So I can do wrap read register, give it the register, and then okay. Great. And then let's do def wrap write register SPI register value, and then SPI.write. Light array. Right. Register. Value. Like that. So then we can do wrap, right, register, SPI, register. No, SPI. No. What was I going to use the right register for? These definitely need to get moved to the top. Okay, so clear flags. SPI.write. No. Okay. Hello, Linux Fish and Dez. Yay. So I've, speaking of being able to join the stream and stuff. I have decided that I think I'm going to try streaming Monday, Wednesday, and Saturday at 11 a.m. Pacific. That way, folks who are working during the day, during the week, can participate if they otherwise couldn't. And all that good stuff. Then that also leaves Tuesday, Friday, Sunday for me to go hike or camping or backpacking or whatever. I have D&D on Thursday nights, so I like to keep that day open. And I just realized that I am going camping. I'm leaving to go camping right after this. And I won't be back tomorrow night for D&D, so I'm going to have to cancel that night, but that's fine. Most people probably were going to be gone anyways. So yeah, Monday, Wednesday, Saturday, 11 a.m. Pacific. And I don't know exactly how to... Like, I can schedule streams on YouTube, but they have to be, like, a video. Like, it has to be... I have to figure out all the stuff. And, like, have a topic and all that stuff. And really, like, I feel like that's a little too formal. Like, and maybe Twitch does it this way too, but I feel like Twitch just kind of like, this is when I'm going to be streaming. I don't know what the fuck I'm going to be streaming, but this is when I'm going to be streaming. Whereas YouTube is like, I'm going to stream this video because it turns it into a VOD. Maybe I can just change it into whatever, or change the topic. Just have like placeholder streams. I'm going to figure it out. But regardless, not going to be streaming until Saturday after this. And I'm about to call it. This code looks a lot cleaner. I want to make it so this actually works. Which is just a syntax thing, so, or not a syntax thing, but the trackpad sort of working. I am able to read values from it and turn it on. By read values, I mean I am reading. Let me just finish this real quick, and you will see what I'm reading. So line 39 takes 3 positional arguments. Oh, because I gotta pass SPI. I gotta make sure. I gotta figure out how to not. Line 59 takes SPI. So I don't want to have to pass SPI all the time. Okay, so right here, this 7 and 3A is the value of registers 0x00 and 0x01, which if we look at these, this is the standard register set. That is the firmware ID and the firmware version. So it's working. I am able to read this, and that part works. That's just awesome to me. To answer your question, Des, what's my job again? My job is currently fun employment. I left my job at Squarespace at the middle of May. Yeah, middle of May. And just have been basically doing this, but not really full time. I don't know. Just kind of relaxing and taking it off. It's been a hard summer, on top of a hard year and a half, on top of a hard career. So yeah, and you know, my goal right now is to leave for Japan June 1st of next year to go backpacking for 5 years. So trying to start another job right now is low on my list of priorities. Although Discord did just get back to me today asking where I'm at to see if they want to restart the interview process. So I might, but I don't know. I have, every time I think about going back to work, I get a little scared. Like it raises my anxiety level. And a lot of that is imposter syndrome, like not feeling like I know what I'm doing at work, where I've been working for, you know, in my career that I've been working in for 20 years. I don't know about in other industries, but in software industries, there's this idea that you fail to the level of your incompetence, or succeed to the level of your incompetence, or something like that. So like people who get to middle manager, they suck at being a middle manager, but they're just good enough to get to middle manager, and then they don't get any more because they suck. And I feel like I'm that way with, like, my next level would be staff engineer or something like that, or maybe even principal, and I'm like, I don't even know. But some of it is because, like, I've always either worked at small companies or Stripe, which was its own can of worms, because I got into Stripe when it was at the elbow of the hockey stick. So like, we went from normal company to hypergrowth company overnight, and I was right there at the bottom. My manager had 30 direct reports. I didn't know what the fuck I was doing. Shit was crazy. Things were broken all the time, and it was just nuts. So it was not a great time. I loved Stripe. I still love Stripe. I'd work there again pretty much in a heartbeat. But I didn't have a great experience there, and it's not... I try to tell myself it wasn't my fault. There was a lot to do with the company, but whatever. And then the next job I had was, I was one of a 2-person ops team, which, you know, levels and promotions and all that stuff doesn't really, there's no, you know, what is a staff engineer on a 2-person team? Like, it's okay, you do all the things and so do they, right? I was more senior than the other guy, which meant that I was mentoring him a lot, but that didn't mean that I was like doing staff level things or principal level things. I got into Squarespace, and they had all those levels, but trying to actually operate across the org was impossible. And then COVID and all this other shit. So it's like, I just, you know. It's, I don't really feel like going back to working in tech right now. There are probably a couple companies that could win me over. I don't think Discord is one of them. But that's only because I think right now they're at the elbow of the hockey stick too. And so I would join there and get lost in the shuffle of the 300 other people who are joining that month or that year or something like that, rather than like having time to get in and be successful and have what I need to be successful. And that's not their fault, right? They're in the hypergrowth phase. Like, oh, we need to hire everyone. Like, fuck it. Just, who cares? Come on. Hire. Because at that phase, you're literally trying to get everyone you can on board. Kind of like throw everything at the wall and see what sticks. And that's a really shitty time to feel like an average employee. I don't know. Anyways, I guess my point is basically that, like, I am probably not going to work until June, and June I'm going to leave and go walk around the world for 5 years. which I'm really excited and terrified about. But it's something that I have done a little bit of. Like, I spent 3 months walking across the South Island in New Zealand. You wouldn't know by the look of me today because I put on 100 pounds since I got back. But as my friend was telling me, you will lose all that weight on the trail. So it's really a matter of like getting to where I can walk 5 miles with a heavy pack, and then it'll just fall off on the way. And I think 5 miles with a heavy pack is doable by the end of by June for sure, if not much longer. But yeah. Anyways, oh, excellent question. Sorry if I just scared you off of working in tech. It's I've been doing this shit for way too long without as much support as I needed most of the time. So going into it, I would say advice wise, make sure you're getting the support you need, and if you're not, get out. There are a million other jobs. Everyone is always hiring is my motto. And if you're halfway decent, you can make a shitload of money. So just save and make sure that you've got a backup plan. Take a couple months off between jobs and feel okay with it. I don't know. Anyways. Yeah, you're 13. You don't need to know what you want to do with the rest of your life. Like, enjoy it. Seriously. I will say, as someone who now really enjoys international travel, 3 words I wish I had known when I was in my 20s, which you're not there yet, but you will get there, is working holiday visa. What a working holiday visa is, at least in the context of New Zealand and Japan, which are the ones that I know of, is you can go to a country, you can live there, you can work there doing any job you want for a year. Or no job. You can just go live there for a year. That means you can go work at, say you go to New Zealand, you can work at stuff. You could work at a bank, you could work at a coffee shop, you could do nothing. But you get to be there for a year. And I think their idea with that is, one, they're just trying to stir the pot a little bit, and also probably a fair amount of stirring the the genetic code pot, right? Small countries like New Zealand, they need genetic input, right? And they need genetic output, right? It's a whole thing. Apparently, that's actually a thing in Iceland too, because they're a much smaller country, about 300,000 people. But basically, what it means is you can go to another country and you can support yourself while you're there, without too much hassle. Like if I wanted to go work in New Zealand. One, I'm extremely lucky that I am very experienced and I work in tech, because that basically paves my route, paves my path to get there. Because New Zealand has a point system. You get a certain number of points based on your qualifications, based on your age, based on your whatever, right? So because I work in a, what do they call it, long-term shortage list job, I would try to work outside of Auckland, which gives you more points, because they just don't want all the immigrants to come to Auckland. They want to spread them around the country, right? Because I have so much experience. I don't have a degree, which actually takes off a lot of points, but I have 20 years of experience, so that makes up for it, and it's actually encoded in their point system. So then I just need to have a job offer, and I basically am able to go. Yeah, you're a special case. You're legally allowed to go live in New Zealand and work in New Zealand. You can't probably right now, but New Zealand is just the example I bring up because that's the one I have the most experience with. a lot of other countries have working holiday visa programs. Japan does. I think theirs even goes up to 35, which I'm 39, so I don't qualify for that either. But Japan has a different program for people who just want to go visit for a year, but you have to have a shitload of money to do it. You don't have to pay a shitload of money. Like, it's like $100 thing to get the application and stuff. But you have to have, like, you have to be able to demonstrate that you can support yourself while you're there. So you have to have something like 30 million yen in the bank or something like that, which is about $300,000. So it's like you have to prove that. Then, so that's not for everybody, obviously. And I don't know exactly what proof is required or what things count because, yeah. Anyways, working holiday visa. Don't forget that that's a thing. If you're in your 20s, look into it because it allows you to support yourself while you're traveling. And international travel is the best thing I've ever done. Seeing different cultures, seeing different parts of the world, meeting different people. It's amazing. And I say the best thing I've ever done, the best individual single thing I've ever done was jumping out of an airplane. If you've never jumped out of an airplane before, go do it. It is the best thing. Hands down. Best single thing I've ever done. And I've done it twice. Go do it. But like, broad terms, best thing, travel around the world. And with working holiday visas, you just need enough money to get yourself landed. You need a flight and some money to support yourself for a couple months or a couple of weeks, whatever. I don't know. There are probably other criteria, but anyways, I'm rambling. My trail name is Tangent. And this kind of thing is why, because I go off on tangents all the time. Yeah. Anyways. And yeah, Leah, you're welcome. I think it's important that we talk more about stuff like this because there are a lot of people who for various reasons, they have family, they have kids, they have personal obligations outside of work, can't work 90-hour, we're gonna code all night and get trashed and stuff, rager coding fests and startup culture bullshit, move 1,000,000 miles an hour, work 1,000 hours a week, work hard, play hard kind of thing. Like, yeah, that's okay, right? But that shouldn't be the norm. And that really should not be any company once it's past 5 employees. 10 employees, maybe, right? Because you're just baking that in, that it's the culture at that point. I also really hate on-calls because on-calls are a double-edged sword because if you are holding the pager, if it doesn't go off, that's your ideal, right? Oh, I didn't get paged last week. But that means you're probably missing something that you should have gotten paged for, or the time you've gotten your alerts tuned and everything figured out so much that when your pager does go off, it's like the world is literally coming to an end. But you also don't want to get paged every 5 minutes because you will want to take your pager and smash it with a hammer. So you've got this balance, and if you're doing it right, you're always available. Given a sufficiently large company, your expectations for response to a page shrinks. So like when I was a Stripe, I was on call by myself over Christmas break once. Like Christmas break at Stripe, nobody works, right? And I was carrying the pager for the entire company. Now, back in 2015 or whenever the hell that wasn't so much. It was a shitload. Like the amount of money we were transacting every day was unbelievable. And they're doing 10 times as much as that now. You can't keep that up, right? But even then it was like, if my pager goes off, we're losing millions of dollars every minute. Like literally millions of dollars every minute that I'm not responding. So the stress level, the anticipation, you know, so when that pager does go off, it's just like, right? And then they're almost always a week-long stretch. They're hard to schedule around and stuff. I hate on call. I hate on call. I hate on call. That's why I'm just kind of like, you know what? I don't feel like going to work this year. I'm just done for a while. Yeah, Stripe has changed so much since I left. But the scale is still there. Someone is still holding a pager at some point for millions of dollars a second at this point, probably. Maybe not quite $1 million a second, but like multiple millions of dollars a minute of volume. Yeah. They're practically printing money, and they gave me some. That's one of the Stripe is a big reason why I am able to not work right now. And hopefully that will continue to get better in the future. I did not sell all of my Stripe stock, but I sold a lot of it. But anyways, I am gonna call it a day because I'm gonna go camping. I have a new tent. So this is my old backpacking tent. It's a Z-Packs duplex. It's a 2-person backpacking tent. And for scale, this is a 20-ounce water bottle. About a large coffee size. And this is my new tent. So put it up here next to this for scale, and I don't have a banana down here right now. But it's about 2/3 of the size. It's the Z-Plex or Z-Packs Altaplex. It's a single pole tent. So you use a trekking pole to pitch it. And it's supposed to be roomier inside. Like I think it's like a 1-person, maybe 2-person tent. But for 1 person, it's much roomier inside because it's taller and the walls pull out further. Because I love my duplex, but getting into it, like I can't sit up in it comfortably. I kind of like this, right? Whereas this tent, I can like sit up in, and it's much more comfortable to like live in for a day. It's like if I'm on the trail and it's pouring ass rain, and I'm like, you know what? I'm just gonna like open this, make some tea, and just sit here and read for the day. I can do that comfortably in this tent, but less so on the other one. So it's a little roomier. Yeah, pitching a tent with a trekking pole, because it's like you're carrying your poles. Like the duplex, they use 2 poles. But this, you only need to have 1, which my plan going forward is to use 1 trekking pole and have 1 with me. Because by the time I was done in New Zealand, I was not using my trekking poles at all because they were constantly in my way. I felt like the only time I really wanted to use them is when I was on a slight incline on relatively smooth trail, because I would basically ski. Because I would put the poles forward, I'd be basically running. I mean, I was moving fast and just pulling myself forward with the poles. But any other time, they were just in my way, right? Like if I'm scrambling over rocks or something like that, I've got to mess around with the trekking poles. No, I'm going to put my hand on something, or I'm going to use a different part of my body to lower myself down off the ledge or whatever. But having one gives you stability on like sidling across things, or you can, in Japan when I was there in 2017, I was walking through a lot of spider webs. So I was doing a little like elephant style, waving a stick in front of me, and that's much easier to do with a trekking pole, just trying to break the webs up before they hit me in the face all the time. And then the second one is a spare. It's a carbon fiber pole, so those don't bend, they shatter. So if I trip and fall and break it, it's gonna explode, and then I don't have a way to pitch my tent, which might actually be dangerous. So carry the other one just to have as a backup, because I can always buy a single pole at a, used gear sale or whatever. I don't know. Anyways, I'm gonna go camping. See y'all on Saturday, where I'm going to try to figure out how to get CircuitPython to do the interrupt-driven loop, and see if we can't read some finger inputs off of this keyboard, or off of this this trackpad. I'm excited with the progress today. I learned a lot, and I have some unanswered questions, but I have functioning code, and that's awesome. So yay. All right, see you later, y'all, and thanks for listening to my ranting about working in tech.